In this video, we are going to begin looking at probabilities. So this whole section of the course, chapters 5 through 7 are all about probabilities. And in this chapter, we're going to be looking at kind of some basic fundamental concepts of probability. In this video in particular, we're going to look at some basic just concepts and terms that we will want to be familiar with as we continue to kind of look at probabilities. The first thing that we're going to look at is the idea of a random experiment. Most of the probabilities that we will be, or really all of the probabilities that we are going to be calculating are for the result of a random experiment. Right, and a random experiment is any activity or phenomenon that meets the following criteria. And I'll leave that up for a second, and then we'll erase that and put some of those criteria down. All right, there are 3 criteria for a random experiment. The first is that there's a distinct outcome for each trial of an experiment. Right, so this one's relatively simple and straightforward. It also just makes sense. We can't have more than one outcome, right? So we conduct this experiment, we do whatever it is that we're going to do, right? We need to get a single unique, not unique, but a particular, that's not even the right way. There needs to be that's why they wrote the textbooks, right? There needs to be a distinct outcome, right? You need to be able to say this is the outcome. It shouldn't be ambiguous or anything like that, all right? So we should have that distinct outcome. The second is that the outcome is uncertain. All right, so before we actually go through an iteration of this experiment, whatever it is, we should not know the outcome, right? It shouldn't be a foregone conclusion, because if it is, that's not a random experiment, because it's not random at all, right? We have a very set particular outcome, all right? So the outcome should be uncertain before we actually do the experiment. All right, and then the third is that the set of all outcomes can be specified and is called the sample space. All right, so those are our 3 criteria or conditions that must be met if we are to consider some activity or phenomenon to be a random experiment. All right, so let's look at a couple of definitions of some things that we put on the board and one thing that we didn't, and then we'll walk through this stuff again. All right, so just so we're all on the same page, right, with an outcome, all right, this is any member of the sample space. Right, another way to look at this is an outcome is just any possible value or value's fine, right? Any possible value that you could get as a result of an experiment. All right, that's all an outcome is. All right, then here something new. This is an event. All right, an event is a set of outcomes. All right, so when we are talking about events, and we will be talking about events later on, that's just saying, hey, for this set of outcomes that are defined, right, we say we want to get all of the outcomes that meet this criteria, right, and then we can say that is an event when we put those all together. All right, so now let's take a look at an example of a random experiment. Now, the ones that we are going to look at for the most part, especially in this chapter, are going to be very simple. And that's just because we want to keep it simple because we're just looking at these concepts, so we don't need anything necessarily complicated, right? But let's say that our experiment is that we flip 2 coins and we record what side they land on. Right. Since this is the first time we're doing this, I'm kind of writing it out a little bit more just so we can really see what's going on here. A lot of times what I would say is just our experiment is flipping 2 coins under the assumption that assuming you will think that recording the result is what we're talking about. Right, but we're going to flip 2 coins, record what side they land on. This is our experiment. Now let's just see if it meets the conditions of a random experiment. So our first condition is that we have a distinct outcome for each trial of the experiment. We would here, right? We're going to have one of 4 distinct outcomes, right? It's either going to be heads, 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 tails, tails, heads, tails, tails, right? It's going to be one of those 4 options, right? We know it's going to be one of those 4. It's never going to be 2 of them at the same time, or, as long as the coin didn't roll under a table and we don't know what the other side was, right? We're going to be certain of that outcome, right? Then for our second condition, the outcome of the experiment should be uncertain, right? Before we flip the coins, we don't know, right? We know that there are 4 possible outcomes, but we don't know which one this specific experiment is going to give us, right? Before I flip those 2 coins, I do not know, right? I can give you a guess with a 25% success rate probably, right? But I'm not going to know for sure, right? So the outcome is uncertain, right? So the second condition is met. All right, the third condition is that we can define, right, the set of outcomes, right, for the experiment, and that's called the sample space. All right, and we can do that. In fact, we already did that, or I already did that just a few seconds ago. Right, we notate the sample space with a capital S. Right, so that's our sample space, and then our sample space is just all of our possible outcomes. All right, so we've got heads, 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 tails, tails, heads, and tails, tails. Those are all of the outcomes for this experiment. We can define them. In fact, we can very easily just state all 4 of those, right? And that is our sample space. All right, so the entire thing, all right, again, the entire thing, all 4 of these, that's our sample space. All right, if we were to just grab one of them, right, say HH, this would be an outcome, right? So any one of these is an outcome, right? We could also define an event, right? Maybe I want to say my event is that we get at least 1 heads. All right, so when we're flipping these 2 coins, you know, how many times do we get at least 1 heads? All right, well, heads, 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 tails, and tails, heads. The only one we wouldn't include would be tails, tails, because of course we don't have a heads in there. All right, so again, right, we've got our experiment. We can run through those conditions, right, see if they meet. All right, any of the simple ones that we're going to be using, especially for these videos, are definitely going to be random experiments, right? But then we can also you know, state our sample space. In some cases, especially when we get into chapter 7 or really even chapter 6, we won't be able to actually write down every single possible outcome, but we can at least specify or define, right, where that sample space is, right, where all those outcomes are. Right, but we can define our sample space, right? We know kind of how to tell an outcome from an event, right, so on and so forth, and we know what we're talking about with these events. All right, but that's it. We will be using these ideas, these concepts quite a lot in the future videos. So if you weren't sure about any of this, please go back, review this video. Let me know if you're one of my students, send me an email, all right, so on and so forth, all right? But that's where we're gonna end this video, and I will see you in the next one.